Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Syahimi. I am from Group 4 for project GEOTECHNICS 2, and today we'll present about the soil nailing and retaining wall for slope remedial technique. So for the introduction, the background study which is at Bukit Antarabangsa is a well-known hillside community in Ulu Klang, Selangor. On 6 December 2008, there was a large landslide was occurred, and a total of 101,500 meter cube of earth has been removed from the slope based from the studies Siti Kasim, Harahap and Osman in 2012. The primary reason of the catastrophe were lack of suitable design and construction methods based from Farisham in 2007. For the problem statement, slope failures are natural hazard that can be dangerous to the public. Slope failure is where a slope collapses unexpectedly due to the weakened self-retainability of the earth. Slope failure occur in Bukit Antarabangsa were caused by heavy downpour rain, which increase the soil saturation and plasticity. Structure of soil is sandy, made the slope failure happen. And the type of slope failure in Bukit Antarabangsa is categorized as rotational failure. The ratio of the depth failure is approximately 15 meter. The slope length was found to be the greater than 0.1. This can be classified as deep seat based from the study Danish Kazmi in 2017. The failure surface in rotating slips might be circular, arch or non-circular curve in section. This type of failure occurs due to sliding material along a curved surface, and such a failure usually caused by groundwater or high poor water pressure within the slope. So important study, there was three major causes of slope failure, which is maintenance error, construction and design. For the design error are diverse in nature and severity. They strongly relate to safety, particularly as they have been known to result in fatalities. And for the construction errors may occur due to failure to follow specific procedures and good practice or outright carelessness. And lastly, which is for the maintenance, the quality of maintenance is highly depend on human activities as it causes many accidents, and incidents have maintenance errors as the contributing cause.
Assalamualaikum. My name is Zari Salina Mizi, matrix number DF190015. I will present the literature review part of our project. Slope failure in Bukit Antarabangsa. International Sabo Association 2004 explained the technical term of slope failure is a phenomenon that a slope collapses abruptly due to weakened self-retainability of the earth under the influence of a rainfall or an earthquake. So this occurrence has resulted in huge losses to the respective locals, including fatalities. The stability of a slope is crucial in geotechnical engineering applications. Slope stability depends on the capability of the soil mass to withstand gravitational forces, additional loads acting on the slope, and potential dynamic loads such as earthquake. Some types of slope failure can also be triggered by other factors such as erosion, precipitation, and human activities. According to the case of slope failure in Bukit Antarabangsa, the type of landslide movement observed is rotational failure. This is according to the author of Danish Kazmi ETAL in the year of 2017. Okay, so in rotational slides, the failure surface is curved inwards and point upwards. The landslide mass is approximately rotates around an axis transverse to the slide movement and is parallel to the ground surface. So the movement is usually associated with shear failure of the ground. The ratio of the failure depth is approximately 15 meters and the slope length is 120 meters. The failure depth was found to be greater than 0.1 0.1, thus can be classified as deep-seated. Next is slope remedial work. According to Pan.W.N.G.Ursioli 2008, the range of slope remedial works are surface protection and drainage, subsurface drainage, slope regarding, retaining structures, structure reinforcement, strengthening of slope forming material, vegetation and bioengineering, removal of hazards, and lastly, special materials and techniques. So corrective procedures according to Broms and Wong 1985. Okay, first one is geometrical method, the second one is drainage method, and the third one is retaining structures method. So these are the examples of each of the methods. So the first one is geometrical methods, is where cut and fill method will be applied, and reducing or halting downslope movement using piles. For drainage method, construct a drainage system to control surface runoff and water seepage. And for retaining structures method, retaining walls are construct using suitable design and materials. Next is soil nailing. So soil nailing is a soil stabilization technique that is used to fix unstable natural or man-made soil slopes as a corrective remedy. This method can also be utilized to allow for the safe over-steepening of new or existing soil slopes. This is according to Surrender Singh 2017. So, according to McGowan et al. 1978, nail is an essential component of soil nailing, and nail estimation, length and spacing is an important part of the soil nailing design process. So, advantages of soil nailing, there are 7 advantages that has been studied by the authors, which are allow in situ strengthening on existing slope surface with minimum excavation and backfilling, allow excellent working space in front of the excavation phase, subvertical cut surface reducing loss of space, avoid unnecessary temporary works, only requires light machinery and equipment, flexible at constrained site and excavation shape, and lastly, robust and higher system redundancy. So the last part is retaining wall. Okay, retaining wall is a type of earth barrier that is used to confine a vertically or almost vertically facing mound of earth. Retaining walls are frequently used to level or maintain slopes, giving them a more vertical character. So according to Muhammad Nur Shafiq 2007, retaining walls may be classified according to how they produce stability, such as mechanically reinforced earth, gravity walls, cantilever walls, and anchored walls. So that's all for my part. Thank you.
Assalamualaikum and hi, my name is Nur Amalia binti Zubaidi, metric number DF190044. I will present a part of proposed technique of soil stability. This part presents the soil nailing and retaining wall are the best choice of technique to remedial the slope failure based on Bukit Antarabangsa. Soil nailing as one of the in-situ soil reinforcement can help increase slope stability. Other types of retaining walls can be used in conjunction with the soil nailing system if it is not possible to utilize the soil nailing system alone for a retaining wall system which is creep wall. Therefore, this project aims to assess combination soil nailing and creep wall. For component of soil nailing system such as soil nail, centralizers and coupler, crudes, corrosion protection measures, nail head facing, connectors, and the last drainage system. For construction sequence of soil nailing, as you can see here, there are 6 steps of constructions of soil nailing. Step 1 is excavation. Step 2 is drilling of nail hole. Step 3, nail installation and grouting. and installation of strip drain. Step 4. Construction of initial shotcrete facing. Steps 5. Construction of subsequent level. And the last, step 6. Construction of final facing. For component of creep wall system. Precast concrete creep wall system comprising reinforced or pre-stressed concrete interlocking or pin stretchers and headers of the dimension, and the system is made up of the interlocking concrete block with the inner space filled with free draining materials, and allows for construction sequence of creep wall. As we can see here, there are 12 procedures of constructions of creep wall. That's all for me.
Assalamualaikum and hi, my name is Afika Binti Ahmad Imran, metric number TF190050. Now I'm going to talk about the standard use for our design. First, I will tell about the soil nailing. Soil nailing entails reinforcing and strengthening existing foundation by placing closely spaced steel bars known as nails into a slope as the building progresses from top to bottom. These are some of the most widely used rules of practice and design manual for soil nailing in Malaysia. The first one is the British Standard of BS 8006 in 1995, Code of Practice for Strengthened or Reinforced Soils and Other Fields. As you can see from the figure show, the application of two-part wedge and also the log spiral analysis for soil nailing. BS 8006 stated that full-scale observation show that the log spiral approach produces a reasonable agreement with actual structure and it provides a convenient platform for calculation when shear as well as tension in nails is to be determined. Alright, for the second one is the US Department of Transportation, the Federal Highway Administration FHWA 1998 Manual for Design and Construction Monitoring Soil Nail Walls. This design approach is identical to both BS 8006 and also HA 68/94. In the design of soil nail, both BS 8006 and also HA 68/94 advocate employing two-part wedge and log spiral failure mechanism, while FHWA advocate using the slip surface technique. The third one is HA 68/94, the design methods of the reinforcement of highway slope by reinforced soil and soil nailing techniques. The design method is divided into two categories for distinct soil nail application. The first one is the design of cutting into horizontal ground. As for the second one is the cutting into the toe of existing slope. Alright, now we'll go to the creep walls. In Malaysia, the following are some of the most commonly utilized creep wall guideline and design manuals. The first one is the British Standard BS 8002-2015 Code of Practice for Earth Retaining Structures. A precast concrete creep wall utilizes less concrete than the mass concrete creep wall of the same size. The pictures show here some common creep wall, which is the timber and or precast. As our design, we use the precast concrete for the creep walls. And as for the second one is BD 68/97, the design methods on the trunk road and motorway network by creep retaining walls. Creep wall can support sloping backfills. BS 8002 clause 4.2.7.2.3 does not encourage their usage in instance where surcharge from building foundation or other may impose loading on the creep wall or its foundation. And that's all from me. Thank you.
Hi, Assalamualaikum and good day to everyone who watching this video. My name is Kamar Afif bin Ablasani and my matrix number is CF190009. In this part, I'm going to give a simple and a short explanation of the study, discussion and a conclusion. For the purposes of this study's discussion, the methodology, functionality, durability and material of the two approaches will be compared. Retaining walls are some of the more classic methods that have been extensively employed, although soil nailing is one of the other methods for slope stabilization that brings better stability. The primary function of a retaining wall is to resist lateral soil pressure in the same manner that a soil nail anchors a steel bar into a strong rock or a soil as a retaining element. For the next slide, Both methods of slope stabilization can be regarded as a permanent or temporary retaining structure with a lifespan of 50 to 100 years. The retaining wall was erected using high-quality concrete and reinforcing bar according to the plan, while the soil nailing was done using a cement grout and a steel bar to strengthen and stabilize the unstable slope. In order to anchor a steel bar into a hard rock or soil, this in situ technique demands the use of specialized equipment. Next, we move on to the conclusion. The first point, common landslide in Malaysia occur as a result of inadequate slope stabilization method and lack of knowledge and technology. Second, the systematic drainage system did not fully work to transfer runoff water to water bodies. Third is high demand for hillside residential areas and a fast development without a sufficient environmental evaluation contribute significantly to landslide. The fourth, retaining walls are widely recognized as the greatest techniques of slope stabilization due to their longevity, utility, and aesthetics in geotechnic settings. For the fifth point, slope with the soil nails are more stable and have less deformation than slope without nailing. 6. The soil nailing method is more cost-effective than other traditional methods for improving and repairing existing slope. Next is flexible facing withstand stresses well, has adequate strength, and exhibit excellent horizontal and vertical deformation. The last point, the combination of traditional methods such as retaining walls and innovative methods such as soil nailing increases the flexibility of building slope stabilization in a wide range of soil, slope angle, material, durability, functionality, and other factors. That's all from me and our team. Thank you.